Hi and welcome to this detailed tutorial on using the DesignPad calculation sheets within GenFEA. So here we've got the model that we produced in the previous tutorials and exercises, the steel and concrete model. So we've got steel elements there. If I right click on any of those elements, choose design group, you'll see we've got concrete, steel and timber and other designs with some elements there for design components. We're going to use the beam design example here, and it says example for a very good reason, and I'll explain in a second. But before we get to that, let's look at what happened. So it opens up the DesignPad workspace, and we can see that there are some values that we need to enter that were not part of the analysis and the input model, and then a bunch of calculations are performed. So this looks really great, but how does it work and what does it do? So by now, you perhaps know that everything in GenFEA is templated. Now, before we get into the template, you can see that it's selected all of the elements of the design group. Maybe we wanted to separate those horizontal beams from the rafters, but that's up to you. Anyway, if we look at the script backend or those calculation sheet backends, you can see that it's actually got a scripting environment, meaning that you can create any script that you wish. There's a specific syntax, and the software explains kind of how to do that, and we'll do more tutorials on that. But for example, if we wanted to extract from frame elements and the design group rafters all of the moments in about the Y, local Y, and let's say we want the extreme values and we want to map them. You see, so graphically we can start creating those variables, and using the scripting language of DesignPad, it means that we can set up these variables to dynamically link to the analytical results and the model inputs. They are even units aware. So you'll see in this example, I'm going to say these are kilonewton millimeters. Actually, it's Newton millimeters. I made a mistake there, but it's just for demonstration purposes anyway. But you can see it's units aware, which means that it can actually keep track of that. And when we save this, I won't save this one, but if we save this in the correct location, so in your documents, BIMWorks FEA folder, and then DesignPad, we've got categories for concrete, steel, timber and other. And if we place this in steel, for example, in the correct location, like you see there, it creates a simple text file. You don't have to edit it in Notepad or in Notepad++. You can use the DesignPad editor. It's much easier to read. But once we've done that, it means that whenever we right click on a results element, so elements with analysis results, we will see those elements appear in the context menu, which means you can pretty much create your own design scripts. And you'll see in this example, we do the column example. It's extracted all of the relevant information and properties from the group columns, and it runs through the calculation as we expect. Now, we also might want to switch on additional components such as nodes if we wanted to do something like a rectangular isolated footing design. And here's an example. So this is one is on the concrete. There's some input values that we need to adjust, things like the concrete strength and the column size. You know, in this case it's going to be 250, sorry, no, 200. So we had columns there of UC 200, so we'll make that 200 and 200, and we'll hit the play button and see what happens. So you can see there's a bunch of calculations, but the important part is none of this is hard coded. We provide examples on how to do this, so you can kind of see how it's done. But the idea is that you create your own design scripts rather than Excel spreadsheets, which produce a much better presenting output, and obviously it's connected dynamically to your analytical results and the model input properties. So there's a lot of value in being able to do that, because it means that you can perform your detailed design calculations and have full control over that to any design standard imaginable. So really simple to set up and very versatile in using, and you only have to set it up once, and once it's been set up, of course you can use that and distribute it across your business. Great, so that is looking at DesignPad. Let's look at some of the other extensions within GenFEA, and there will be more to come in the future. But we can also connect our design elements by selecting the chain of elements and looking at the results plot view. We can see, you know, the output values and the plot view, but we can also send this to other design modules. In this example, we're going to send it to the Structural Engineering Society of New Zealand's MEMDES application. We developed this in collaboration with the developers of MEMDES, and what this does is it gives us that same plot output with a slight variation, that it actually does beam segmentation according to the New Zealand steel design standards. And we can see here we're looking at the moment ZZ at the moment, and we've got that point of contraflexure where that line crosses the blue line, and that provides the two segments based on the selection of rafters in that model. Now we can go ahead and save this and specify the file save location. So we're just going to change this to the memdes format. We're going to specify a path location and a name, and we'll just place this in the projects folder here. So we'll go to let's go up one folder and let's place that in projects, and we'll just put it in memdes there, and we're going to specify a name. Right, so we'll just call this one training tutorial, and we can then see we've got a bunch of values populated there, like the segment length, there's the section type and grade, there is a bunch of other settings as they relate to the memdes module, and then for flexure already those values populated, same with axial, and if we wanted to add some of the fire or advanced features, we can do that. Now when we hit the export button, it's going to create the memdes export file, and we can simply double click on that to run it, and it will then go ahead and open up memdes with that particular file. It'll automatically add that section to the database, and all we need to do is to go to results and click on the calculate button and start viewing the calculation results. So there we go, we can see the outputs based on the memdes calculations directly exported from GenFEA. Simple as that. Right, I hope you found that useful. Thanks for watching and see you soon. Goodbye.